Welcome back. I'm Chris Sikora. I'm here to show you today a little bit of sheet metal inside Creo Parametric 6.0. In this exercise, what we're going to tackle is what you see there on the screen. It's an assembly with some gears and a pulley, and we need to create this enclosure over it so no one sticks their hand in there. And we're going to do this sheet metal project in top-down terms. So basically, we're going to design the sheet metal inside the context of the assembly. So if this is like a rear casting here that holds the sheet metal on it. If that ever changes, our sheet metal should adapt with it. In the advanced classes, you're going to see coming up after this class, we're going to cover sheet metal several times. We're going to look at conical sheet metal parts, cylindrical. We're going to look at some more advanced sheet metal capability. Not really advanced, it's still not super advanced, but more than what we're going to cover here. This method here goes back to a long time ago. It actually works really well inside Creo. I really enjoy using this one. So let's go ahead and let's get started. First of all, what you need to do is you're going to need to download the assembly files. And so if you go to the Vertanu, V's and Victor, ERTANUX1, don't forget the .com, and then go up here to Part Files, and then in the white column, make sure you find E11 parts. Now, this is for the educational version. The non-educational version, if you're running that, then grab the non-EDU parts. Okay, when you click on it, just go ahead and hit download. And depending upon your browser, it might show up in the lower left, might show up in the upper right. It just depends on wherever. I'm just going to click on it here. It brings up, they're compressed, so you can just click and drag a fence around those, or Control A to select them all. Go ahead and you could cut them or copy them, and then go ahead and put them in your Creo. Go to New Folder, and you could go ahead and create an E11. I already created an E11, so I'm going to call mine E11B. And then you could just double click on that, find the E11B, double click on it again, make sure you're in it, and right click and paste. You could also right click on the folder and paste too. I just want to make sure that you found the folder. And then here you'll see the actual parts that are needed. So inside Creo, you just close this out. To bring these parts up, you basically just go to File and Open. Now I'm going to go ahead and close mine out and start from scratch so you can see what this is all. Okay, so I restarted Creo. That's just only because I showed you I actually did them here. Now, if you'd like, you could actually go to that Vertanu 1 and under instructional manuals, there's the Creo Parametric 6.0 training guide. And this is almost at the very end. There's actually, after this, there's the final exam, there's a lab, and there's some bonus information on picking out a processor as well as a computer that you might want to use to run this, whether or not if you're doing it from home or if you're actually at a company. I just give you some little tidbits of information, but by no means, you pick out what you want ultimately. All right. Now, I'm going to go ahead and go to Open. I'm going to go to my Creo folder and the E11B. And it's the E11 assembly, which is the assembly that you want. Hit Open. And it should look like this. Now, I have little louvers on here. We're not going to learn how to do the louvers today. But you can see a preview of what it should look like minus those louvers. We're going to actually put in air vents instead. So, little cutouts. So what you want to do is, what I'd recommend is turn off all of these, the datum display filters and things like that. And now click on this part and go ahead and hide it. And now you can just see your pulley and the two gears. Now we're going to go ahead and build around it, the enclosure, just to show you how easy it is. It's actually pretty neat how this works. Okay, first of all, we're not going to go into the sheet metal tools. Notice when when you create a new part here, we're not going to create a new sheet metal part. Now that is another method, and I'll show you in future versions. I forget what it is. It might be E16 or E17. But anyhow, Let's go ahead and go to Create. And notice here you have Part. You do have the capability to select sheet metal. We don't want sheet metal. We're going to do it in a different way. I'm going to show you tools that don't require the sheet metal component right away. You can actually just model it up and then turn it to sheet metal. And I think with new students, it seems as though it makes more sense because we're using the same tools that you've been learning over the past several weeks. But let's go ahead and name this now. You could just call it cover, and just in case, go underscore B because I have a cover in there already. So you want to label it cover underscore B and hit OK. And then here, copy from existing. Yep, just hit OK. All right, now with our new part, you can see we could manipulate it if we want, but just as always, I'm always recommending, for this intro class at least, the default. That will drop it on the origin of the assembly. So our part and origin match up, if you remember that from the last few exercises we've done like that. Okay, now just go ahead and hit OK. And don't forget to click on the cover B now from the model tree and activate it. Now, of course, you don't see anything there because you have to create it. So go to Extrude, and let's select, let's say we want it to come off of that edge there, or off that surface, I should say, and be aligned to that. Go ahead and select that. Now, we'll flip it upside down. That's quite all right. Go ahead and now we're going to try and steal these edges here. So don't hit OK. That I was almost going to hit it. Go to Offset. Now, the reason we're going to select Offset is so that our sheet metal is going to be 0.062 inches thick. And we're going to offset it so it folds above the actual casting that you see there. So around it, we can put some screw holes in there for fasteners. But let's go ahead and let's select Chain. Click on this edge and hold Control, select this edge, and it should wrap around. Go ahead and hit Accept. And it's going to create a loop. That's fine. Hit Yes. You're probably asking, why did you just create a loop? The loop, you could select this surface right here if you wanted to. I just don't like the preview. Like, this preview is much better. It's bright green for my students. I could point it out. It takes more of a discrete eye to be able to see the light and dark blue for the preview for the loop. So that's why. Okay. Now here we can see the arrow right there is pointing outward, and that's what we want. So we don't have to type in any negative number, just a regular number. So 0.062 and hit the green check. And now you can see the offset of our sheet metal. Go ahead and hit OK. Rotate this, and you'll see it's going out the wrong side. So hit this little arrow right here to reverse it. Now grab this little dot and drag that in with your mouse pointer. And let's go over here. Click on this little arrow to the right of the depth and select the one with the red line in it, which is extrude to select the surface, edge, vertex, curve, plane. Now select like this this corner on the back side because that's what we want it to fold over. And look at that. Okay. Now it's solid. That's quite all right. You'll see in a moment. Hit OK. And there it is. Now notice there wasn't any specific sheet metal tool we used for that. We just went and we extruded it. So you can do that with sheet metal and then later on transform it. Now here's what we want. We want to shell it out so it's thin-walled, 62 thousandths. And then we're going to select the faces that we want to remove. So that's where now we're going to convert it. You have to go to the operations right here and find convert to sheet metal part. Now I know that's not too obvious, so but once you get the hang of it, it makes sense. But go ahead now, you'll see there's driving surface and shell. We actually want to shell it. If you model it this way, use the shell technique. All right, now as we rotate around here, there's our casting right there. You can see the text for the direction and such. We actually want to remove that face, but before we do that, type in the thickness 0.062. And what I meant to show you again, well, I'll show it to you in a little bit, is the actual options for the defaults on here. If you want to change the default settings, when we get out of this editing this part, we could go to the options and we could actually go in, and there's a sheet metal area where you could put in like what you want as a default. Do you want to use a K factor, for example, as a default? And what K-factor do you want to use, and all these other settings. So be aware that there's those options, and I will show you where that's at. Okay, so 0.062, go ahead and select this face, and the preview, I really like this preview. It shows you inside the box. Now, we're not done yet. We want to remove a few more faces, so you have to hold Control. Select this bottom face here, rotate around, and this big flat face here, hold Control, select that, and finally, release Control as you rotate, because otherwise it'll pan. I release Control. Now I'm going to hold Control again to select this face. So make sure you select 1, 2, 3, and 4. The order doesn't matter, so don't worry if you select them out of order, that's fine. But it should look like this is what you should have when you're ready. And go ahead and hit OK. Now, it shelled it out, but it's not, it is a sheet metal part now. You can see the sheet metal tools are up and ready for us to use. And they have a whole array of tools in here. We're only going to script the surfaces with this basics class. That's why it's called the basics class. Even though this is more of an advanced thing, it's still neat to show. Designing sheet metal is a lot of fun, actually, in my opinion. All right, so what we're going to do next is we're going to go ahead and convert it. Now, I know you're thinking, well, didn't we just make it a sheet metal? Yeah, what we did essentially is we shelled it, and then it went into the sheet metal tools, but it's not officially sheet metal just yet. You have to go to conversion. Now, there's these options here that we'll step through. First of all, this one that we're in, we go to placement here. This is the edge rips. And so, like, see, these are connecting faces that we want to remove so we could flatten this out. Because the ideal situation here is to get a flat pattern, just like when you break down a box for recycling. When you break it down, there's a flat pattern there that that box originated from, and that was folded into its shape. That's typically how sheet metal is created. It comes out of its flattened state with the cuts in it, and then you just fold it up. And that's what we want to do here. Okay, but so go ahead and select this edge here, and then hold Control and select this edge right here. And immediately you'll start to see little rounds come in, or fillets. And again, in the options menu, you could change this when we're going to go after we're done. Now, for the edge rips, let's rotate around this side and zoom up, and you can see what it's going to do. Oops. Maybe this is a better view right there. You can see it completely notches it out with the default. But look at here, instead of the seam type, instead of open, you could go to blind, and you could set the distance gap right here. You could go to gap and set the gap from corner to corner, or edge to edge, I should say there. Okay, and there's some options here, like I'll just set it to 2 for a second so you can see that. It's a very large opening. And there's 0.5, we'll stick with 0.5. And then there's overlap, and that's where basically you see one surface overlaps the other, and we could add a gap between it there, and there we added a gap. Let's actually turn off spin center here so it could rotate around that point. Spin center is very nice. I always forget to show it. Turning it off no longer spins from the centroid of the model, thus it doesn't spin out of the screen when you turn. So it actually picks up wherever your pointer is and spins around that, making it a temporary center. So look at that, we could rotate. And then when you're done, now look at this, I'll zoom out, it zooms around, there's the spin center. All right, so we've seen different options there. Now be aware, sometimes I've seen it where you can make it a little too tight. You always want to have, in my opinion, I like to add gaps. In reality, sometimes I can't have it, so that's where Creo gives you the option. But I've seen sometimes when it's just a little too complex with the sheet metal and you have to work with it. But that comes with experience. All right, now I'm actually going to go back to just open, and I am going to have a little gap in there. We'll leave it just as is. Don't narrow the corner, sorry. All right, now hit the green check, but we're not done yet. Now look at this, the next one is the Rip Connect. All right, and here we have some tools for placement. We want to add additional ones. I believe, actually, I can't recall exactly a good application for this particular one here, but let's just hit OK. My apologies on that one. It's been a while since I've read up on some of these. The edge bend, let's click on that. And now here under placement, you're able to actually add additional bends off of edges and things. We're not going to go into that just yet. Again, I'm a bit rusty on that one. And then finally, the corner relief, and we have V-notch. Now here's the thing, the corner relief, like in this corner, is the example where you might want to put relief in. Now right now it's set to V-notch, and it's literally a little V cut in there. And where this comes from is if you've ever wrapped a gift in wrapping paper, those of you might, especially those of you who aren't familiar with sheet metal, when you've wrapped it, sometimes in corners you'll see when the paper starts to ripple a little bit around the corners. Putting in notches helps to relieve that, so it's more of a flush connect or area. And so it's recommended sometimes that you put those in. You can't always have them in, but there's V-notch, there's normal, okay, that's a normal, like a rectangular sort of opening, but they have rectangular too. They're circular, so there's a little circular opening there. There's square, and you can change those parameters too, by the way. And there's rectangular, and that kind of is like the V-notch. Comes in and looks like at an angle, but it still makes a rectangle. And finally, there's ombre. Now, what you would use these for, again, it's remember to make a nice smooth corner transition wherever the bend is going to take place. Ombre is good for die punch sheet metal. So if you're using a die, those of you who never been in a sheet metal shop, basically imagine the hole punches that you use to punch paper. Normally they're round, and the reason for that is because imagine punching that 1,000,000 times, it's going to wear evenly, or the hope is that it'll wear evenly when it's round, versus if it's rectangular, it's going to wear at the corners. So for punch, they might request ombre. Now rectangular or square, those would be used for, they're pretty easy just to notch them out, for laser, water jet cutters, plasma cutters maybe, although plasma cutters aren't very accurate with small of a piece. I guess you could do it on a large sheet. But anyhow, there's circular, and circular, I actually haven't seen circular, I'll be honest, I haven't seen circular used in industry. I actually designed some sheet metal parts for cabinetry and things like that. And one thing we did use, what I worked on, we used like no relief, or some color rip. And basically, when we were making stainless steel countertops that were going to be used for medical industry or food service industry, the corners you don't want to have any sort of opening in there, because as you know, when you wipe down and try and clean those areas, any sort of opening could trap organic material. Organic material could grow bacteria, pathogens, you name it, could get caught in there. So you want to mitigate that. And if you have a rip, which is basically, it's just a little slit, it's a much tighter corner. And those corners can be treated, mind you, through a variety of processes, welding, but just note that there's different reasons, and check with your fabricator what they want and give them what they need or what they want. Okay, so I'm actually going to go with the ombre. All right, and if you go to the to this, you'll see there's actually, it actually shows you even better the little imagery there. You have a lot of options in there, and I'm not going to go through them all. I'm going to hit the green check. All right. Bend allowance here. We're in the general settings here. In the bend allowance, as I mentioned before, these are in the options menu, the default set it's going to use. But if you want to override those, you could go to use part settings or use feature settings. And for example, you could go with the K factor or Y factor or by bend table and specify it, just actually the bend allowance itself. So in the Midwest here, it seems as though K factor is used quite a bit in my experience. So you'll see 0.318. Creo does a great job. That's kind of the sweet spot, and it seems though, in industry. I've had customers that when I've done designs for, I helped students even who work in sheet metal fabrication facilities. and they tested it with like 0.5. And one of my students said when they were bending everything at a 0.5, after the design was 0.5, they were almost 30 thousandths too big, the enclosures that he was making. So when he actually used like 0.3, he actually used 0.32, and he said they were coming out perfectly. But that again could vary on your fabricator. Check with your fabricator. They might have different setups and things like that. So, all right. And finally, let's just go ahead and hit OK. And so now we have the bends in there. Now what we're going to do is we want to add a little flange here, because if this ever needs to be serviced, for example, if a serviceman needs to replace that belt, they want to be able to take this off. We don't want them to cut their hand on a sharp piece of sheet metal. So let's put a little bend in here. So let's try, and the flange is great. Flange you could use for a lot of neat things here. And what we're going to do, select this edge right here. And you can see it's going out in the direction we're not really wanting. We want it to go in like this. And go ahead, once you get it in a little bit, go ahead and type in 180, not point, and you'll see fold in on itself. And then zoom out here, change this to 0.25. There we go. And there's some settings in here as well. You can see profile and edge, bend outside, offset bend. So there's a number of different options you can choose from. And also here you can adjust pretty much anything you want. Go ahead and hit the green check. So we have now a little bend taking place under there. Now to cut the screw holes, there's little fasteners that need to hold this on the top. Go ahead and select this face, go to extrude, and you'll be able to see them when we go to wireframe. So let's go over here to hidden line, and there they are right here and here. So we could actually, one of the easiest things I found, if you just go with the circle, wake it up, drag it out, make it equal. Do the same over here. Oops, click on circle, wake up by hovering over the edge, get to the center, drag it out, click. Now you can use the offset, or you can use the project, which gives you the same area, but there's usually a couple segments. Sometimes there could be more than 2 segments I've seen from time to time on certain items, and that complicates a little bit more. So just a nice round circle makes it easy. All right, hit OK. And I'm going to go to shaded with edges so you can see this. And you can see it's cutting into there. Okay, the 2 holes. Hit the green check. Now let's cut these out too. Select this face, go to extrude, and you can just use the circle. Now you would probably want a little clearance on these ones, so you could use the offset. I'm just going to make them equal. Hit OK, and you can select through all. Now what's neat here is that you see here there's remove material normal to as well as to the driving surfaces. I don't really have a good example to show you. It would be like, let's say on this surface, are you going to put that hole in while it's in its flattened state? By default, it will know if you design it like that, that the hole is straight. You know, we're talking about the 60 thousandths wall of the sheet metal. Now, if you disable that, and if you had it coming in, like if you're actually drilling it as it's bent already in the manufacturing process, it might look more like this because it itself, the flange was at an angle and you're coming in from the side. So those are options to toggle that. So you might have more an elliptical shape, and you might have sharps at the 2 corners. Okay, hit OK. All right, and now what we're going to do, let's put in the little cutouts for ventilation. Now to do that, we could model it in the 3D here, but I want to show you how to model it in the 2D. And we'll actually stay in this assembly. You could open up, as I've shown you in earlier ones, we've actually went to open. If we actually activate the E11 assembly, there's a little folder you could open it up and isolate it, you might say temporarily. But I want to show you how to put something in, especially if it's over a bent area. So what you want to do is you want to unbend. Now you'll see here, this is what it looks like in its flattened state. Now maybe you don't want this as your fixed face, so you could actually click in here and select this as your fixed face, and everything unfolds from it. It depends on what perspective you're working on. Okay, but now that we have that, we hit OK, and there it is in its flattened state. Not done yet though. Let's rotate this. We want to cut out right on the surface, so hit the extrude button, and let's put in a rectangle right about here over that, and then let's dimension it. We'll make it 0.2 by 2, and the offset here by 1, and then the offset here 3. So it's right on that edge. Okay, now that we have that, we can hit OK, and you see it's cutting. Just make sure it's cutting through. And now we're going to pattern that. So under editing, you go to pattern. Now if pattern is grayed out, you have to select that extrude 4 from the model tree right here. But if it's active, that means you're good to go. You can just select pattern. Select it. Now, instead of dimension, let's go to direction and select this edge right here, either one of those edges as a direction. And then go ahead and set the number of instances that you want. So we want 5, and we're going to spread them out a 1/2 inch. Now you're not seeing a preview here very well, so let's go back to, let's see here, what am I looking for? All right, we'll just, I'm going to go to sketch view, but all right. We can see it needs to be reversed, so just hit reverse here. Okay, and hit OK. All right, now it looks like we could fit another one in there, so to edit it, just right-click on this, and click on the D1, and then just double-click on that 5 extrudes, change it to 6, and then middle-click a couple times, and hit regenerate in the upper left. All right, we're ready to bend it back, so hit bend back, hit OK. And now you can see the actual cutouts right in the middle of a bend. So we have our ventilation. And now what we want to do is we want to make this into a, export as a DXF file. Now DXF stands for Drawing Exchange Format. It's a neutral file format that's been around since the 80s as far as I know. And it's used for transferring, especially for water jet cutters, laser, plasma cutters. It's almost like the standard to translate files. So what we're going to do is we're going to export a flat pattern drawing of this. To do that, let's see here. So what we're going to do, if you click on flat pattern, it gives us a flat pattern. Go ahead and hit OK. Now hit the little arrow next to flat pattern and create an instance. Okay, and we could call it cover B flat. And what this is, it's like a family of parts. And so we'll actually make a part file that just for our drawing. So hit create. You could name it something else, but we'll go with cover B flat. Hit create. And the reason for that is because we don't want to have the flat pattern locked in here. So go ahead and just click on the flat pattern, and we're going to suppress that. All right. Now let's click on E11 assembly and turn on activate. And let's go to file, open. Now we never saved this part, so it should be in session. Find in session, and then find that part, the see, there it is, cover B. Now watch this. When you click on cover B and hit open, it'll give you 2 instances. So we want the cover B flat. Now it's parts isolated, and now we can make our drawing from this. So let's go to File, New, Drawing. And we could use the drawing file name, that's fine. Hit OK. And we could probably go with the C-size drawing here. Remember, you could also go empty or empty with format. I'm going to go with the use template because it's pretty much blank anyway. Hit OK. You know, and here you'll see actually if we go to general, just hit OK, click to drop it, and let's go to front. Oh, actually it would be top. There we go. All right, the reason why I'm doing this is I don't want these drawing views, so I'm just going to click on those, hit delete, click on that, hit delete. Could have actually clicked on the bottom left, it would have deleted it. Now, notice here we have the scale that it automatically scaled so it could fit on that sheet. Double click on that. And up here, let's change it to 1. And now that's 1 means full scale. Now to move it, click on it and then go to lock view movement. Basically, you're turning it off because it comes in already locked. And then double click on it again. And let's make it so that it's useful for us to output as a DXF. So what you want to do is go to View Display and go with Wireframe. Oh, actually, better yet, probably no hidden because you don't want anything that might be captured in the back. And as far as tangent edge display, you might want to find out from your fabricator what helps them the most when doing this. But I would think maybe go with Phantom because they might not want the tangent edges on there. And hit OK. All right. And so there it is. Now you would just go to File and do a Save As and Export. You can see there it is, DXF. And you just go ahead and hit Export. And it'll export a DXF. And then they can import it into their machine and actually cut it. There are some neat videos. Those of you who are interested in watching this, feel free. I'll show you a couple little things you could see what a water jet is. Just on YouTube, you can actually look these up. And so like here, I just typed in water jet, and like right here is a multi-axis water jet. And you can see it's using a very powerful jet of water with ruby in it, and it's actually and cuts out those shapes. And so this is why you want the DXF file, because it can feed it in. Let's put in laser. A laser CNC cutter, and right here, oh, here we go. I'm not getting paid by any of these people to show this stuff. I'm just all right. And how about a plasma CNC cutter? All right, let's take a look at this one. This one actually looks like he's got some video showing
everybody today at
the actually showing the DXF probably brought in, or whatever file format he was using. And you can see it on there, and here it is, cutting out that shape. Actually, precision on that looks great. I actually mentioned that they might not be all that precise, so just the ones that we have at the college don't seem all that precise. But these more expensive industrial ones are pretty darn cool. Okay, so anyways, there you can see some examples why you'd want to be able to output this file, especially in its flattened state, so that could be prepared for that. All right, the next part of this, let me open up our training guide here, is to make this timer base. And so I'm going to go ahead and download it and open it and rotate it. And I'm not going to go through the whole thing. Oops. There we go. It's on page 106. And I'm going to rotate that. All right, so this should match up with the part we did last week for the lab. And what we have is, again, 4 by 2.5 inch rectangle, and the thickness is 0.35. So I'm going to get out of that. To go to New, Part, and this will be L11B. And we'll do it on the top plane. Go to Extrude. Go to Center Rectangle. Now, you could do it like top down, I guess, if you brought in that other part. You could actually model it around it. It might be easier for an experienced user, but I'm not going to do that. All right, and we'll hit refit here.